Hey everybody. So if you did not intend to attend a monitoring talk, this is not the not right one for you. And this is your chance to leave before I get upset that you got up and walked out in the middle of my talk. Somehow I made a right turn instead of a left, and I wound up here instead of at Monitorama. And so let's talk about Chef and why I think monitoring is so important. A lot on monitoring. I love monitoring. Monitoring is the most foundational thing that we can do in our infrastructure. It is more important than config management. Now, if you don't see me tonight, it's because I just said that. But monitoring. I almost wanted to put on my sweaty shirt and dance around like Jeff Ballmer because monitoring is super important. And so you get this wealth of information in your monitoring system. And so this talk is going to be about how do we have access to that wealth, that state of our infrastructure from within the Chef client, which typically only has a small view of what's going on around it. I'm also going to show you a little bit of code that I wrote that illustrates how to do what it is I'm saying is so important. So let's move forward. Let's see if I can go to my second slide. Here we go. Okay. This is really a common infrastructure architecture. I draw a lot of pictures. I'm the chief architect at New Context. And so customers want to see pictures. So I get involved in the pre-sales as well as the post-sales process. So that means I don't just get to draw pictures. I also have to go implement the thing that I drew. And so I care what it looks like. As you can see, this is simple, right? This is a small site. It looks like there are 3 load balancers with different IPs. You've got 6 servers doing something or another. They're orange boxes because we don't really ultimately have to care what they're doing at this moment because I just made this picture up in 5 minutes. And there's lots of complicated routing that happens between them. It looks like there's a cache and a database server with a slave and a replica, read-only replica, maybe some S3 buckets or something like that to store data. Y'all have probably seen something like this before, is that right? Okay. Now, we monitor servers. We monitor a lot of servers, but we don't really care about servers. Like we were hearing about this morning, we care about outcomes. We want to ensure a certain level of service. And so we monitor servers as a proxy for services, which are in turn a proxy for outcomes. That will be important moving forward. So let's talk about how monitoring systems work. Now, we know that we do push versus pull. Now, what does that mean exactly? That means in a push situation, the monitor services are pushing interesting information into a central monitoring server or servers, which will then collect that state information, filter it, chart it maybe, determine whether there's something actionable, some reason to notify an administrator that something needs to happen. And a pull-based system means that the monitoring system is polling. So this is more common. You'll have a monitoring system and it has a list of, 1,000 servers or something like that, and it's sending out a predefined list of queries to all of these servers and gathering all this information out. There's a polling loop. Often it's parallelized as well. But in general, the more servers you have, the longer it takes to collect a single snapshot of information. And you're pretty much guaranteed when you have a large number of metrics that you're monitoring that the ones that you obtained data from at the beginning of your polling loop will have different data than the ones that you obtained at the end of the loop, just because of that time differential. It's impossible to get a pure snapshot of your infrastructure. So that's the polling thing I'm talking about here. Now, once you've collected all this data, you can collect it into a time series database. InfluxDB is an example of this. Prometheus does this. Even Nagios, the OG monitoring system from the 90s, does this. It has this proprietary database that it stores current check results and a little bit of history in so that you can query back and figure out what happened in the past. Finally, there's event filtering, because not every piece of data that comes in is actionable. We only want to alert an administrator if there's something that absolutely requires the administrator's attention. And in my opinion, whenever we get alerted, if I get paged, that means that there are two problems. Problem number one is whatever I was called on to remediate. Get up out of bed, log into the server, rub the sleep out of my eyes, whatever. And the second issue is that I got paged in the first place. Because why couldn't these incredibly intelligent systems that we build resolve the problem themselves? So this is what I just said, written up. The outcome should be correcting the issue and increasing the intelligence of our systems. Now, we're at ChefConf, so we know some really interesting things that we can do with the Chef client. Okay, so we talk about metrics. We've defined a metric might be, for example, what is the current CPU utilization on a system? Or it might be how much virtual set size of memory is assigned to a process. This is traditional. We don't need to talk about containers here because on the infra level, everything is a process. So we can talk about first order metrics. Those are the ones that I just called out. CPU utilization on a single node. That's a first order metric. This is terminology that, as far as I know, I'm making up. So if you've heard other terminology for this, please come to me after this talk so we can discuss it. But a first order metric is one thing on one system at one point in time. These are simple things. These are things that are easy to get at right now from within the Chef client. Is the service running? Heck, that's built in. We can just say it should be running, and Chef client will remediate it. Here it is in a pseudo-mathematical expression. M would be the metric, N would be the node, and T would be the time. You add them up, and you get 3. Now, I think that second-order metrics are more interesting than first-order metrics. And that's when I take any one of these points and I turn it into a line. Just one of these points and turn it into a line, because when you turn multiple into a line, it gets even more complicated, and this is really hard stuff to understand. So for example, multiple metrics on one node at one time. That's one thing turns into a line, the other two stay as points. Follow me so far? So multiple metrics, that would be memory utilization and disk I/O increasing together on one node at one moment, or not increasing, sorry, are high. And that could mean that the system is thrashing, for example. We can tell that just from reading 2 metrics on one node at one point in time. We can also consume one metric on multiple nodes at one point in time. And this is so valuable in our current infrastructure style, because we rarely will run a service on one node in our infrastructure if we care even the slightest about it, because having run infrastructure, we care about our systems being up. So we run clusters of applications. And if I have 20 servers running the same application behind a load balancer, and one of those servers goes down, I don't want to get woken up by it. I have 19 more. I'm going to have to lose 18 more of those before I even start to pay attention. But with a lot of monitoring systems, and especially if you're only worried about first-order metrics, you're only going to alert in a very simplistic way. So the administrator is going to get woken up. Service died at 3 a.m. on node 19, and you've still got 19 more that are running the service. So this diverges from this principle that I was saying, that we are interested in outcomes. The cluster status would be readable as one metric on multiple nodes at one time. How is the overall health of the cluster? That would be, service being up, for example, I'm keeping it simple, on the whole class of nodes that are responsible for that service at that time. We can also talk about one metric on one node at multiple times. An example of how this might be useful is looking at, say, log disk utilization. If my log disk is filling up at a rate of 1% per month, and it's just reached 90%, don't wake me up. But if it's filling up at 1% every 10 minutes, wake me up. We will deal with this. Now, there's still two problems, because that means my system was misconfigured, and I have a potential disk full situation. So I have two things, two incidents to fix. Now, one principle of monitoring that I care about a lot as well is descriptive monitoring versus prescriptive config management. Config management is where we define a specification of what our environment is supposed to look like, and the config management software is then responsible for making it so. Monitoring, on the other hand, will describe that same desired state, but it will not make any alterations in order to make it happen, because the point of monitoring is only to alert an administrator when human intervention is required. Monitoring is capable of doing remediation in many cases. And I believe that that functionality overlap should be minimized, because if you're going to use your monitoring system to remediate your service situation, why are you using config management to begin with? You can just use monitoring for everything. Also, remember that monitoring typically runs as non-root users, but the Chef client runs as root. So if you do want to use your monitoring system to configure everything, you're going to wind up either running your monitoring agents as root, which stinks because they are historically insecure, or you're going to wind up with a whole bunch of sudo rules that you're going to have to maintain, and you're going to have a brittle infrastructure. You're going to wind up monitoring those sudo rules while you're at it. It's a terrible mess. So use your monitoring for monitoring, use your config management for config management, and let the two live together. I made up this scenario this morning during the keynotes because I thought it was fun. And it's a fun little hypothetical scenario about using monitoring with Chef that illustrates how I wouldn't want to do it. Okay, so let's pretend for the moment that a system administrator is responsible for a meth lab. As any smart engineer would, this system administrator uses Chef to manage the configuration of the systems. This is a meth lab. It's full of volatile substances, and it's prone to unwanted law enforcement intervention. And so there's a number of sensors. And so this system administrator, doing what they know, pulls out Nagios, hooks it up to the sensors with some Perl glue, and creates a system that looks somewhat like this. On the top left, you might see we have a fence. There's some sensors attached to that fence in case the fence is breached by some unknown party. We've got intrusion detection, and then we've got Nagios doing its thing. You notice the lion on Firefox. It's a pretty awesome theme. And then we have Chef. Now, Chef is retrieving data from this Nagios, and when it runs, it's going to set off an alarm if the fence breach service has gone critical. So far, so good? All right. No surprise to anyone, the SWAT team shows up. But the system works exactly as designed. The SWAT team comes out, and they cut the fence. 9 seconds later, Nagios detects the breach, and it sets the service to critical. 27 minutes later, Chef runs and activates the alarm. Success. Works perfectly. Clearly, this illustrates that monitoring data can be dangerous, and the use case for Chef is not necessarily alerting. So let's talk about the dangers, like delayed action. Chef runs by default every half hour. And the solution to this problem is not just to run the Chef client every 15 seconds. Have you been in a place that ran it every 5 minutes or something like that because they just couldn't keep their servers up? So delayed action is a risk. Stale data, monitoring systems poll. That means that it's very likely that the data that you're getting from the monitoring system was valid as of some time period in the past, some moment in the past. And during the interval between when that data was generated and the Chef client consumes it, changes could have happened. It's still important to know that so that you can make good decisions instead of bad ones. It introduces additional complexity because you have to think who's doing what, where did this data come from, did the Chef client see something different locally? You've got more moving parts. And that means more things that can break, more things to monitor, and more reasons to get woken up, which stinks. There are more failure modes because there are more moving parts. You have to think about what about the link between the Chef client and the monitoring server? What happens if the link between the monitoring server and the things that it's monitoring goes down? What happens if there's a bug in the code that I wrote that talks to the monitoring server? But it's also very useful when we're trying to do things across a modern set of services. A quorum-based deployment, for example. I want to deploy my application using Chef to a set of nodes. But if that node that the Chef client is running on at that moment is the only working node in the entire cluster, I probably don't want to deploy to it at that moment. Maybe I want to wait until things look a little better, next Chef run or something like that. Another case is in provisioning automation, the same sort of thing. If I have 5 dead nodes in a 6-node cluster, maybe I'd like to tell my provisioning to spin up some more. Master role assignment. Have you had situations where you're spinning up a number of nodes in parallel in a cloud or something like that, and somebody needs to be the master and others need to be replicas of this cluster of machines? They're all coming at the same time, so you can either declare that the first one on the list, according to some naming convention, becomes the master every time, or you can say, hey, monitoring system, do we have a master? If not, I'm going to become the master, and if so, I'm going to become the replica. But monitoring data is inherently at risk of being stale, so you could wind up with 2 masters in that case. This is where distributed logging becomes useful. You can also weave together a cheap kind of service discovery. If I need to know what is the IP of the active load balancer for this situation, I can ask the monitoring server. It should know. So now let's talk about how we can make this monitoring data available to the Chef client. A lot of monitoring services have APIs. APIs are awesome because that means that I don't have to store the data anywhere else while it's on its way from the monitoring server to the Chef client. Data bags are another way to do it. I could write some sort of a program that would regularly poll the monitoring server and gather together all the information out of that monitoring server based on current and historical state, write that into data bags, upload that to the Chef server, and then the Chef client only has to pull those data bags. But I'm not a big fan of that because in the environments that I set up, we start at 10,000 metrics, and a big complex environment could easily have upwards of 1 million metrics, which means that my poor Chef client is going to be downloading all this data every time it runs. And this could easily overwhelm the monitoring server or the Chef server just because of the sheer volume of data. So that's not a good fit. What about OHI plugins? This was another thing that I started trying out. Maybe I can write an OHI plugin that'll run on each of my Chef client nodes that will download just the relevant bits of information about that node or the services that that node cares about. That got really complicated really quick. Doesn't work so well. Let's say I can implement the same thing as data bags using local files written to disks or an external database, but that has all the same problems as data bags. So that's not really a solution either. We're trying to minimize overhead. We're trying to maximize simplicity. We want to get access to these metrics so we can act on them. And we don't want extra things to monitor. We don't want extra things to break. You can probably see my perspective on this. I've been woken up a lot of times. So let's implement this right now. I've written a little bit of code ahead of time, just so you all don't have to watch me type. But Can you see my screen? It's not very bright. Is it dim? Don't be shy. Is it small? People in the back? I have terrible eyesight, so I feel for you. I'll make a bigger font. Talk to me. All right. Thank you. All right, so you can see that I've got a cookbook called Prometheus Metrics. And there's not really a lot going on in this cookbook because this is a library cookbook. All I want to do is use whatever ChefDK gives me to talk to my monitoring service, which in this case is Prometheus, and make that data available to whatever chef client, whatever recipe or cookbook is wrapping this cookbook. So all the interesting stuff is going to be in my tests and my libraries. So let's go to tests first because we all test first, right? In production. All right, so I wrote a quick spec, and let's talk over what this does real quick. So I have a fake API URL because I'll be stubbing out my Prometheus server. I don't actually need a Prometheus server in order to write a test for something that consumes data from one. And I sure as heck don't want the people who inherit my cookbook to have to spin up their own Prometheus server every time they want to test my stuff. So there's my favorite method is at the end, so I'm going to skip to that. This current cluster health. So it looks like the scenario that I had in mind was that I only want to do an action, for instance, deploy my application, when the current cluster is healthy. And so then I have to describe what healthy and unhealthy, what is the happy case and what is the sad case mean. And so I made a sad client and a broken client, and on top I have a happy client. That's the normal client, just called client. And so what I've defined is the three behaviors that we have to think about. If the cluster is unhealthy, then I don't want to deploy. If the cluster is healthy, I do want to deploy. Now, broken is a funny case, though. Broken means I can't talk to Prometheus. And so as an administrator, I have to decide how I want my chef client to behave in that case. Do I want to say, well, I don't know what the cluster's like, so I'm just going to go ahead and deploy? Or do I want to say, it's probably not safe to deploy? And that depends on your use case. My personal preference is to go ahead and do it, because maybe something I did is what broke the contact with the Prometheus server. So if we use our monitoring system, let's see, sorry about that. OK, anyway. So far, so good? Y'all have all written tests before? Everything else is deep implementation tests. For instance, when you will see in a minute, and when you see, you will understand. All right, so let's go to the libraries. And you can see I wrote this library called Prometheus Metrics. Raise your hand if you've used a library before in Chef. OK, great. Nothing special here. This is just a pile of helper methods that I'm making available to any cookbooks that wrap this, or that exist on the same environment that lists this as a dependency. Let's see. Here we are. Now, I'm using JSON Client. JSON Client is a class that comes with the HTTP client gem. I picked the HTTP client gem not because I thought it was the best thing on earth, but because it's already included with Chef. You don't have to install anything additional on your system, which means less config to manage, less stuff to break. And that's how I like it. I'm using syntax folding in case you're wondering what this weird Vim screen is. It lets me control the drama. So putting this into Chef recipe, I typically will make a module full of methods and just include that in the class that people use. I find that it's a little easier to relocate the code when I do it this way and refactor things. Now here's the fun part. So we have an initialize method that will go into whatever class includes this module. And that just takes the base URL for my Prometheus server. I can pass that in as a node attribute into the recipe that calls it or something like that if I see fit. Or I can even use a fancy resource if I want to get that far. And then very simply, I have a health method that will call whatever query it is I give to the client and give me the result from the JSON that comes back from the Prometheus API. Also very straightforward. So health expects a block, or a query and a block. A query is anything that's searchable for metrics or status in Prometheus. And then the heavy lifting happens over here in this current cluster health method. Now, for the purposes of this presentation, I shoved this all into one class. In a real production implementation of this, I would split this up, most likely, and allow the wrapper cookbook to inject the current cluster health method into the containing class. That way, it could be stored right with the code that's responsible for maintaining the services that comprise the cluster. So what does this code do? It checks the result. Now, in this case, the result is a scalar. What that means in Prometheus land is that I get a timestamp. It's an array with 2 elements. The first element in that array is the timestamp, and the second element is a number that indicates, in this case, the percentage of nodes in the cluster that are healthy. The reason I chose Prometheus for the purposes of this demo is that it's easy to put together second-order metrics. I can make metrics that are purely composed of other metrics. So I can say, hey, Prometheus, I want you to monitor the status of this important service on each of these 20 nodes, but then I also want you to have another metric that is the percentage of nodes that are reporting OK. And that makes it really simple for me to consume the current cluster health. I do one query, cluster type, cluster health. Cluster type might be www, or it might be API, whatever it is you need to have. And this is my made-up naming scheme. You probably have your own. And if the result is that less than 50% of the cluster is healthy, then I say no. Whatever it was you were thinking about doing, don't do it, because that's bad. Otherwise, say OK. And if I can't talk to Prometheus, that's OK too. Just do whatever it is you wanted to do, and we'll assume that everything's fine. How might I use this in a recipe? Well, let's have a quick look. What do we got here? OK, first of all, I always put a comment when I put in code that runs at compile time, because it tends to bite people. I write most of the Chef code for people who don't know Chef as well as I do. And I don't want to get woken up. And I don't want to get bothered if I don't have to. So I say, note, this runs at compile time. So I connect to the Prometheus server. I'm referring to a node attribute, the name of which I made up. And I pull the current cluster health. If I get OK, we good. If I get anything that isn't OK, then we good will evaluate to false. So far, so good. And then I just touch a file. Do not push unless we good. This is a very simple example, but I think it illustrates the principle that I'm trying to illustrate. All right, moving along. Many monitoring servers have APIs. I picked a few off the top of my head: Prometheus, Sensu, Isinga, who is downstairs, in case you haven't chatted with them. They have a pretty awesome API. That's read-write, in fact, so you can change API. You can change metric stuff using that API. There's Nagira. In case you're still on Nagios, you can have an application that provides API support so that you can actually have a reasonable RESTful API to communicate with Nagios. I just grabbed that from 6 or 7 of them on Nagios Exchange. SolarWinds has a REST API, as does Xenos. And I'll bet you that whatever your favorite monitoring product also has one if it's not on this list. All right, and the obligatory, we are hiring. New Context is always looking for sharp engineers. We do a lot of consulting and services. We also develop products around lean security, which has a lot to do with DevSecOps, but isn't only that. And I'm open to questions.
Questions, anyone?
Do we have questions?
So you mentioned that there were several that work with on that last slide there. Does that
Yes.
work with all of the kind of the main monitoring providers? For instance, we use the BMC tools. Mm-hmm. Would that be able to tie in to that piece?
Chef can query anything that's queryable. And so as long as whatever your favorite monitoring toolkit is has an API, you can talk to it, and you can support it from the Chef client. Any more questions? I know it's getting late in the day, and you've probably heard a lot of people talk at you.
All right. Well, can I get a round of applause?